Hello dear student, in this video we are going to solve chemistry unit 2. Okay, unit 2 past paper. So first question is, which equation represents standard enthalpy change of formation of hydrogen iodide? Standard enthalpy change means when the temperature is room temperature about 298 Kelvin and temp pressure is almost equal to 100 kilopascal. Okay, so hydrogen exists in I2 form at at standard temperature, and iodine exists in solid at room temperature. So it is in gas, so it won't be. It is solid, but the formation for 1 mole, it is forming here. It is forming 2 moles, so it won't be. Okay, in this it is gas. Iodine is also in gas, so this will also not correct, because uh, iodine solid exists in I2 gas at 140 degrees Celsius, and it is not room temperature. It is not this much temperature. Okay, so from here D is correct answer, because D is in solid. This one is solid and it is making 1 mole, and when you will add, here is 1 hydrogen, here is 1 iodine, total Hi. Okay, so D will be correct answer. Now question number 2, when 50 centimeter cube of hydrochloric acid of concentrated 2 mole per decimeter cube is added to 50 centimeter cube of sodium hydroxide solution of concentration 2 mole per centimeter cube per decimeter cube, the temperature increased is 13 degrees Celsius. The equation is given. The experiment is repeated using 25 degrees Celsius, the same hydrochloric acid, and 50 centimeter cube of same sodium hydroxide. Then what will be temperature? What is the temperature increased? So first we will solve delta H for this equation when we have taken 50 and 50. Okay, and after that we will calculate temperature when it is taking 25. So what we can do, delta T is 13 in degree Celsius, or it is equivalent to 13 Kelvin when we are taking difference. So unit won't change. Now total volume of solution is 50 plus 50, 50 plus 50, 100 centimeter cube, and if the density we assume is equal to 1 gram per centimeter cube, so the weight of solution will be 100. Okay, so the weight of solution will be 100. Q is equal to mc delta, where m is mass, c is specific heat capacity, which is 4.18 joules per gram per Kelvin, and this is delta T in kelvins. So after multiplying these numbers, we will get 5434 joules. Now we can find out the number of moles. Now number of moles we can find out by using concentration times volume. Concentration is given to us 2 moles per decimeter cube, and this is volume in centimeter cube, so we will convert in decimeter cube by multiplying this 10 raised to minus 3 times. So after that we will get 0.05 decimeter cube. So 0.05 decimeter cube, and from here the number of moles will be 0.1 moles. Now we will use formula for finding out delta H, that is minus Q upon N, and Q is 5434 minus 5434, because of this one is for formula, and divide by 0.1. After calculating we will get minus 54.34 kilojoules per mole. because this is minus, so this reaction will be exothermic. It will release heats. Now we know delta H for this much mole. Now we can calculate the number of moles for this volume. So the concentration is remained same, and now the volume changed. So the new mole is 0.05 moles. Now we know the delta, we know Q minus Q. We will, when we will rearrange this formula after multiplying this, the minus Q is equal to delta H times N, and delta H is minus 54.34 into 0.05, and after this you can subtract this minus and this minus, and you will get new Q for this reaction when we take in 25 centimeter cube. So the Q is 2717 joules. Now you can use Q is equal to mc delta, and we are going to find delta T. So divide Q by mc. Q is 2717 divided by mass. This is mass for 25 plus 50. So 75 times 4.18. After calculating, you will get 8.66. So you can round up this by 8.7. Now question number 3. Nitrogen reacts with hydrogen to form ammonia. Okay, the reaction is given. N2 gaseous form plus 3 H2 gaseous gives you 2 moles of ammonia in gas. Now the enthalpy change of reaction is minus 92 kilojoules per mole. Bond energies is given. Okay, and what we are going to need to find, what is the mean bond energy in kilojoules per mole for NH bonds, for NH bond. So we can use delta reaction, enthalpy change of reaction as this, and this is comes from the summation of bond broken minus summation of bond made. This is the formula you can use, and here this is minus 92. And how you can write this? Because the bond broken, this is bond broken, left side, this is reactant, so this will break. These bonds break, and the bond breaking bonds are given to us 945 plus 3 times, because 3 into HH bonds, 3 times 436 minus 6 times, because in ammonia it is like this. So 1 2 3, and this whole multiplies by 2. So 3 into 2, 6. 6. E represent mean bond enthalpy. This represent mean bond enthalpy of NH bond. So after calculating, you will get 390.83, which is nearly 391 kilojoules per mole. So option D. Now question number 4. How many moles of CO2 are formed when 3 moles of chloroethene, this is the formula of chloroethene, is mixed with 10 moles of oxygen and react as shown? Okay, it is given 3 moles of this. When 3 moles of chloroethane reacts with 10 mole of oxygen, then how many moles of carbon dioxide forms? So first, see here, 2 moles reacts with 5 moles of oxygen. 2 moles reacts with 5 moles of oxygen, and 4 moles of carbon dioxide. So 2 moles of chloroethene required 5 moles of oxygen. So 3 moles required 7.5 moles of oxygen. How? 2 requires 5, so 3 required X. After calculating, you will get 15. This cross multiplication, you can do cross multiplication. So 15 by 2, here you will get 7.5. So 7.5 moles of oxygen required, and it is given 10. Okay, it was given 10. So this is in excess and it is in and this is in less quantity. So we will directly compare this with this. So 2 moles required 4 moles. Now 3 moles will require 6 moles. 3 moles require 6 moles. So you can see C is correct answer. Now question number fifth. Which compounds are arranged in order of decreasing boiling temperature? Decreasing boiling temperature. First, uh, see the number of carbons. So this is here 1, 2, 3, 4, 4, 5, and here is 6. So as we have already studied, as number of carbon increases, the temperature of boiling temperature increases. So in straight chain, more the number of carbon, more the boiling temperature. As the number of carbon increases, boiling temperature increases. Okay, so this will wrong because it is decreasing order, and this will, like, this is the right order. So you can see B as correct answer, but why not C and D? So we will see here, and in this there is hydrogen bonding. Okay, there is hydrogen bonding, so they will be stronger. There is hydrogen bondings. Okay, these will do hydrogen bonding, so it will be also increasing, and because of this CH3 and boiling point increase with an increase in atomic masses of halogens. So because of iodine mass is greater, so the boiling temperature should be greater for iodine, iodomethane, iodomethane, bromomethane, and chloromethane. So order should be like this, but it is reverse order. So from here you can say B as correct answer. Now question number 6. Chlorine is added to 2 centimeter cube of dilute solution of potassium iodide. The equation for the reaction between chlorine and iodide ions is Cl2 aqueous react with 2I minus aqueous gives you 2 aqueous and 2Cl minus aqueous. So you can see the oxidation number for chlorine, it is 0, and in this it is -1, so it is reduced. Oxidation number is decreases 0 to -1. So because of oxidation number decreases, it means it gains electrons, and gaining electrons is reduction, and if this is reduced, so iodine minus will oxidize, and we have read if the quantity is reduced it will oxidize the other one. If chlorine will reduce, so it will oxidize iodine. So iodine oxidize iodine ions reduced chlorine because it is oxidized, so it will reduce. So iodine oxidizes, so it will reduces the chlorine. So from here B is correct answer. Iodine ions oxidize chlorine. No, this is not wrong. It is reduced. Okay, chlorine reduces iodine ions. No, it is oxidized, and chlorine is either oxidized or not reduced. No, so B is correct answer. When the reaction is complete, 10 centimeter cube of chlorohexane density of this is added in the mixture. The mixture is shaken and left to settle into 2 layers. What happened when this reaction is completed? When this reaction is completed, so 10 centimeter cube of chlorohexane is a organic compound. It's an organic compound. Its organic compound is added and it is shaken, okay, mixed and left to settle down into 2 layers. Which description of these one of these layer is correct? So solubility of iodine in organic solvents such as cyclohexane produce a purple solution similar in color to iodine vapors. So upper layer will be purple because it makes purple when iodine reacts with organic solvents such as chlorohexane. Chlorohexane, when it will reacts with a purple color solution will be formed. So A is correct answer. Going from calcium to barium in group 2, which property charge changes as stated? Okay, when we are going to down from calcium to barium, which of the following properties changes as status? Ionic radius decreases. No, ionic radius increases down the group. First ionization energy decreases. First ionization melting temperature increases. Now reactivity with water decreases. Down the group reactivity increases, down the group temperature decreases, but ionization energy decreases. This is right because as the size increases, the distance between attraction between the nucleus and valence electron is reduced. So first ionization energy decreases down the group. Question number 8. The property of group 2 compound change down the group from magnesium to barium. Which statement is correct? Okay, which statement is correct? Solubility of group 2 sulfates increases? No, it decreases. And beryllium and magnesium sulfates are readily soluble rather than, but the sulfates of calcium, strontium, and barium are not. These are not soluble, but beryllium and magnesium sulfates are readily soluble. Solubility of group 2 hydroxide, it increases because of hydrogen because of hydrogen bondings. And thermal stability of group 2 nitrates increases. Yes, this is right one. And thermal stability of group 2 carbonates, it decreases. Now see the reasons here. uh, the size of anion being much larger compared to cation, the lattice enthalpy will remain almost constant within a particular group. Since the hydration enthalpy decreases down the group, solubility will decrease as group 2 metal carbonates and sulfates for carbonates and sulfates. Because the decrease in lattice energy of hydroxide salt by the increase in the coordination number of the metal ion as group as you go down the group. Okay, as you as you go down the group. Now question number 9. So from here question number okay, answer C will be correct. Now for question number 9, iodine reacts with hot sodium hydroxide solution. Okay, a reaction is given to us. Sodium hydroxide aqueous reacts with iodine aqueous, gives NaI aqueous, NaIO3 aqueous, and water liquid, and their coefficients are given. So what I have right here, A means sodium for sodium. This is sodium, N, C, and D. So A is equal to C plus D. This is our first equation. Now for balancing O. So A, now 3 times D and 1 time A. So A is also equal to 3D plus E. Now one more equation for A. This is H, and here the only H. So A is also equal to 2 times E. Now for B, you can write B as B because it is only for iodine. So here iodine and here iodine. So 2B is equal to C plus D. Okay, 2B plus 2B is equal to C plus D. Now you can do one thing. You can write 2A as E, 2A as E. So after solving 2A, instead of A you can write 2E. ठीक है. Instead of A you can write 2E is equal to 3D plus E. Now you can take this E from left side, so E is equal to 3D. E is equal to 3D. Now you can put here E is equal to 3D, so you will get A is equal to 6D. Okay, you will get A is equal to 6D. Now you got A as 6D. You can see see A is equal to 60. A is equal to 60, so you can write here A is equal to 60. D plus D, so C will be 5D. Okay, C will be 5D. And after that you can find here 5D plus D. 6D divided by 2, 3D. So you got 3D. And D is equal to D. So you can see here, after substituting the value of D as 1, because in the D option the value of D is only 1, otherwise you have to check for putting the values like 1, and after putting 1, let's say here is 2, so after putting 2 you have to check like A is 4 or not, B is 2 or not, C is equal to 3 or not. If it not matching, so these answer will be not. But in this case it is easy because all the option for D is only 1. So you can put D is equal to 1 and you will get the A as 6, B as 3, C as 5. Okay, C as 5 and E as 3 and D as 1. So 6, 3, 5, 1, 3. So D will be correct answer. Now question number 11. Ethanol can be prepared by reacting chloroethane with aqueous sodium hydroxide. This is chloroethane. This is aqueous potassium hydroxide. When these reacts, which type of reactions occur? What type of reaction occurs in this preparation? So you can see here, this OH group replace this Cl group. So you can simply say it's a substitution reaction. So D. Now B part of the same question, how do the melting point of ethanol and chloroethane compare, and what is the reason for difference? So ethanol is higher, ethanol is higher, ethanol is lower, ethanol is lower, ethanol is higher. Ethanol molecules forms hydrogen bonding. Yes, ethanol molecules form hydrogen bonding because ethanol is like this, and the first molecule is like this, and second molecules is like this. So the lone pair of this oxygen makes the bond with this hydrogen, and this is called hydrogen bonding. So, and hydrogen bonding is stronger. So from here it is A. Now question number C. Bromoethane and chloroethane reacts with aqueous potassium hydroxide at different rate. Bromoethane and chloroethane reacts with aqueous potassium hydroxide at different rate. Why? So which is correct? So see here first, C and F, when bond length of C and F is like this, now the C and chlorine and C and Br and C and I. So as the bond length increases, bond strength decreases. Okay, as the bond length increases, bond strength decreases. So the bond length of Br and Cl, bond length of CBr is greater, so it will be weaker bond, and if it is weaker, so it is easier to break, and if it will break easily, so it will be faster. So B is correct answer. Now question number 12. Butanol burn completely in oxygen. Butanol burn completely in oxygen. Okay, and the MR of butanol is given, molar volume of gas it's also given to us. Now 7.4 grams of butanol was burned completely in 16 decimeter cube oxygen and mixed, uh, and the mixture of gases produced was cooled at RTP. Okay, a mixture of gases produced was cooled at 2 RTP. Now if we will see this equation, so 1 mole of butanol reacts with 6 moles of oxygen to produce 4 moles of carbon dioxide and 5 moles of water. But here, how many moles we have taken? It is take 0.1 moles. So if we have taken 0.1 moles, so how many moles of oxygen is required? So number of moles of oxygen required is 0.1 times 6. So you will get 0.6 moles. And if you got need 0.6 moles, so 1 mole needs 24 decimeter cube. So this much mole needs how many moles of oxygen, sorry, how many volume of oxygen. So volume of oxygen is 0.6 times 24, it is 14.4 decimeter cube of oxygen is required to burn 7.4 grams of butanol. So number of moles of carbon dioxide produces, because 1 to 4, so 0.1 to 0.4 moles, so 0.4 moles. Now the volume of CO2 gas produces, so volume of CO2 gas produced 0.4 times 24. It is 9.6 decimeter cube. Sorry, it will be 9.6 decimeter cube. 9.6 decimeter cube. Now we have already taken 16 decimeter cube of oxygen, but in the reaction it is used only 14.4. So oxygen remains, how much oxygen remains? It is around 1.6 oxygen remains. Okay, 1.6. And we have calculated the carbon dioxide forms 9.6 decimeter cube. So total, okay, we have to find the mixture of gases produces. So the final volume of mixture gas in decimeter cube, so 9.6 plus 1.6, so total will be 11.2 decimeter cube of gaseous volume of mixture of gases. So if, now question B, if the final mixture of gases is passed through U tube containing sodium hydroxide, what is final volume of gas in centimeter cube? So sodium hydroxide is a base, and in the reaction a carbon dioxide and water is formed. So carbon dioxide is a acidic, because it's a non-metal oxide, so non-metal oxides are acidic. So acid and base will react together and it will form salts plus water. So there will only a gas, that will be oxygen, and that will be how much? 1.6 decimeter cube, and you have to find it in centimeter cube. So it will be time 1000 centimeter cube, and after that you will get 1B as a correct answer. Now question number 13, a halogenoalkane is dissolved in aqueous ethanol. When aqueous silver nitrate is added, a white precipitate forms immediately. Okay, so it's immediately, so we have to check the rate of reaction, which will be faster. We have 1 chlorobutane, 2 chlorobutane, 1 chloro, 2 methyl propane, 1 chloro, 2 methyl propane, and it's 2 chloro, 2 methyl propane. So it's a 1 degree, it's 2 degree, it's 1 degree, and it's tertiary, and it's 3 degree. So because the stability of carbocation is tertiary, then secondary, then primary, so it will become faster and therefore this will form immediately. So 13 D is correct. Now question number 14. Propanol and propanone are isomer which M by Z peak should not be expected in the mass spectrum of propane. So you can write the formula of propanol and propane. So the mass of this portion is 2 carbons, so 12 into 2 plus 5 hydrogens, so 29. So here you can say B as correct answer. Now question number B. Propanol and propanone can be distinguished by chemical test. Which pair of observation is correct? Okay, which one is correct one? So Fehling solution shows positive test for aldehydes. So if it shows positive test for aldehyde, so there will be some changes, but here no changes. So option A is wrong. Option A is wrong. Add solid phosphorus chloride. Okay, add solid phosphorus chloride, so there will be some changes. Propanol, when it's added with propanol, so reaction will be like this. There is some changes, and when it is react with a ketone, I mean propanone, so it will be reacted and form this product. So in it will react for both, but here no changes, so again this will be wrong. Now warm with acidified potassium dichromate. Acidified potassium dichromate when reacts, so it will form acid carboxylic acid or it will be oxidized. So it will change, turn to green, but propanone won't change. So here we will not, there we will not show any changes. So option C is correct. So thank you for watching the video guys. Okay, if you like this, please like and subscribe.